Hey everyone, this is SIG Scalability meeting, 25th of May 2023. And today we have LTT tracing demo from Benjamin, and I give you, you can just start.
Okay. Can you see my my deck?
Yeah.
Okay. So hi everyone. My name is Benjamin Sensé, and I'm a graduate student at Polytechnique Montreal. I'm doing my master on performance analysis of Kubernetes through kernel and user space tracing. I'm here to present to you a tool I've developed that can help you do performance analysis on Kubernetes. Although it's still under development, I'm eager to gather your feedback and perhaps explore potential use cases where my tool could be useful. So allow me to provide some background information for those unfamiliar with the concept of tracing. You might have heard of open tracing or even eBPF. Essentially, what a tracer do is record event that represent what a process was doing at a certain point in time. As an example here, we have a client doing a request to the backend, and the backend doing a few subtasks. So the events would be the client starting a request and then ending the request, and then the web app starting the processing and then ending the processing. And with all of these events, you can create a sequence diagram that represents the critical path of your request. But the issue is that from one trace to another, maybe you can see here that the task one is taking more time compared to trace A. And there's no way to know exactly why it was slower. It's kind of a black box. And so kernel tracing allows you to better understand why the task was blocked. So in the second example, you can see here that using kernel tracing, you could see that task one was blocked by task one from trace A because it was waiting for a few ticks. And basically, a kernel tracer collects system calls. So that way you can know more about your system. And using a tool like Trace Compass, you can better understand the critical path of each processes. You can better understand, you can see the CPU usage, the memory usage, the disk usage, and a lot more things. So the kernel tracer that I'm using is LTTNG. There's many kernel tracer like eBPF, ftrace, perf, but I'm using LTTNG because it's the only tracer that's both able to collect user space event and kernel space event. And it's also one with the least overhead. So what I've done is added a few trace points inside of Kubernetes to collect events. This way I can generate two views inside of Trace Compass. So let me show Trace Compass. So here you can see Trace Compass. This is a tool to analyze kernel traces. As an example, I've traced a simple deployment of a single pod on Kubernetes. Using my user space instrumentation, you can see all the events in the life cycle of this pod creation. You can see the deployment being created. You can see the replica set being created, and you can see the pod being created. So you can see all the phases to create the pod. You can see it being pulled. You can see it being started, and you can see it being killed. In this pod, I've created, on purpose, I've put a really low quota. So when you zoom in on the pod being started, you can see the small spike here that indicates that it was being throttled, which is a common case. And when you look at the control flow of your system, you can see that all my processes were preempted, which basically showed that my pod was being throttled. Also, I can look at, in this case, the polling was really slow. It took 13 seconds. And basically, to know why it was slow, I can look at the critical path of container D. Container D was the process that was pulling the image. In the more specific view, you can see all the time it was preempted, so it's a bit cluttered, but there's an overview view here of the critical path. And you can see the reason why it was slow. So in this case, you can see that it was preempted a lot for like unpick Z, other container D processes. It itself was preempted a lot. It waited a lot also on the timer and a bit on the network. So yeah, so essentially trace compass and kernel tracing allows you to get more information on what was actually happening on the kernel. You can see also the disk activity. You can see which process were running on which CPUs at each time. You can see the complete control flow of the processes. So that's essentially the information we can collect and process using LTTNG and Trace Compass. So thank you for listening to my demo. Do you have any question or some feedback?
Yeah, this looks pretty cool. I was actually wondering because on the lowest one, you also have scaling deployment and replica set. How do you get this information? Because my understanding before was that the LTTNG is kind of like kernel thing, but here on the traces, you can see also the deployment and replica set here, right?
Yeah. So basically, LTTNG can collect every system call being called and record it. But it's also, there's a library called the libLTTNG-UST that allows you to send events, to record events from user space. So what I've done is added, I've created my, basically I've added like a few call to that library inside of Kubernetes. I've compiled my own Kubernetes. And from Kubernetes, I've called the kernel tracer to add like a lifecycle event, like being pulled, started, killing, etc.
Yeah, so this is pretty cool because I think like actually last time on the SIG meeting, we were discussing kind of similar thing where we were interested in tracing KubeVirt latency of creating VMs, and something like this would be also really great, I think. What do you think, Shyam and Wojtek? This looks like pretty interesting tool.
Yeah, I fully agree, and I think we I'm not sure I'm not closely involved in like the tracing related efforts that are driven from or by SIG instrumentation, because I think they are integrating with open tracing, if I remember correctly. I think it would be good to present that also on SIG instrumentation meeting and get their feedback and understand why they chose open tracing and whether we may potentially want to revisit that. I'm not super familiar with any of those, so it's hard for me to tell that, but they would be good people to talk about that too.
So I'm guessing that open tracing is not as gradual. The granularity of open tracing will be much slower, much bigger compared to LTT tracing, right?
It can be, at least, yeah.
Yeah, so like that's one of the pitfall of Kubernetes of open tracing that I was explaining is like sometimes you can see that one task is slower from like one trace to another, but like you cannot go further. Like,
so Benjamin, you said there was a way for you to plug in like this kind of custom events that like the user space events that you're plugging in using this library. And you also said to be able to do this, you had to kind of compile, like make some code changes to the components to kind of emit certain events and stuff. So I think it will be interesting to see if the same kind of or the similar method is possible with the open tracing proposal that Wojtek is talking about with SIG instrumentation. Is like the things that you've changed here, can they also be plugged into the other solution that the community today is thinking about? If not, then this would be a good place to bring it up. That hey, I'm able to do this with LTT, and it's the same thing isn't working there. I'm personally very interested in tracing too. So happy to get you in touch with some of the folks in SIG instrumentation on this.
I think one more interesting thing from our perspective would be to see it for the control plane nodes and not the worker. Like from user perspective, usually probably they care about like why the pod was starting slow. But from scalability perspective, I think it would be also cool to see it for the control plane.
yeah.
So my question would be like actually how much effort did you have to put in to actually integrate it with Node basically, or Kubelet and Containerd?
So the thing so essentially the kernel space instrumentation, you get it like for free. You just have to install a kernel module and you'll be able to collect every trace event that you want from the kernel. For the user instrumentation, so in this case, this view, the issue is that the library is in C, so I had to use CGO to call it. But otherwise, it's like pretty easy. It's just like a system call.
Okay.
So I know a class of users, at least a class of customers today that do at least the kernel side of tracing using eBPF probes. I think you also mentioned eBPF. So you can install eBPF users probes and kernel probes, for instance, right? And I know how much of this, for example, Cilium, I believe, does a bunch of telemetry gathering. Maybe Marcel, you know.
Yeah, basically all of it using eBPF.
Yeah. So I think I guess from what I sense, where the community is heading, and I might be totally wrong, is for these kernel operations, right, or even user space operations, like let's say changing IP tables and stuff like that, with or let's say networking configuration and stuff, using eBPF to gather that is something people already do today. And the open tracing proposal that's floating around in SIG instrumentation, I need to go check where that is trending towards. Maybe Wojtek, you know more about it, but I suppose that's purely Kubernetes space, like all the controllers and all these operations like image pull.
Yeah, I think for now it's pretty much only kubelet and API server.
Okay. And what you're proposing here, Benjamin, is one single solution that can do all of this. So again, I think I'm going back to the same point I was saying previously, is it'd be good to check with other folks the direction we've taken and why we've taken that direction.
So yeah, you have like open tracing that collects user space event, and then eBPF that collects kernel space events.
Yeah.
So the issue is like when you're trying to combine both of these events, the issue is like it's not really that precise, the timer from open tracing. So it's hard to correlate events from like your kernel trace, which is usually like in nanoseconds, compared to your user space trace that is in microseconds. So that's one issue with like combining these two traces. And then LTTNG is able to combine both. But also eBPF adds more overhead than LTTNG does when tracing. So that's just one issue with eBPF. So yeah, what I'm proposing is essentially like one solution that combines both user space tracing and kernel space tracing with the least overhead.
All right. So under the hoods, how are you collecting? How is LTT collecting if is not using eBPF? Is it a completely new thing or?
No, so that's the thing is like eBPF is like computing things, but LTTNG only like it only like copies things in memory. Like it doesn't touch at all. It just records events. So that's why it's really fast and efficient.
Okay. Okay, I see. Cool. Overall, I think this is super cool to watch as well. The other part I think we haven't talked much about is the how you're visualizing this, like this tool for visualizing. Is this also part of LTT or this can this work with like in general the open tracing standards, like it can inject traces in specific format and stuff where maybe we can, I guess it's a little bit down the lane, but I think it'll be cool for us to have this sort of a visualization for our tests that we run today. Just like the SIG runs today.
Yeah,
so going back to my question, actually, what's this tool that you're using?
Trace Compass. Yes. So Trace Compass is just like you don't have to use Trace Compass to analyze LTTNG traces. There's also a library called Babel Trace that allows you to essentially like read your trace files and create your own custom analysis for it. And like I'm sure you could use another front end. But what's nice with Trace Compass is that there's a lot of like analysis that have been built upon. It's a tool developed by our lab at Polytechnique Montreal with also Ericsson. So yeah, so it's just like a tool to analyze trace, but you don't need to use this tool to analyze traces. It's just really convenient.
Okay. Cool. Thank you. Yeah, I think maybe once you check back with SIG instrumentation, feel free to let us know what we are thinking as a project. You can use the Slack channel to also we bring up any follow-ups with this SIG. Like we can, for example, say what sort of things we usually look for.
Okay. But I've actually talked a few months ago with SIG Scalability. What they said is essentially that like I could reuse their trace point with like open tracing. And they were like open for me to like integrate it into Kubernetes. But I guess I'm just like looking for more use cases before like integrating.
You mean you talk with the SIG instrumentation, right?
Yeah, I had a meeting.
Okay.
Yeah. I mean, they're open for it, but yeah. I was just looking more for like use cases inside of like Kubernetes, like people that would appreciate, want to see certain things using kernel and user space tracing. I know you mentioned like a control plane.
Yeah, also, but I think I'm wondering like if the KubeVirt, like 2 weeks ago, we had exactly similar conversation with the issue of debugging, kind of like why does it take so much time for VM to spin up in KubeVirt? And they were actually like interested in tracing. I'm not sure if like they need like kernel tracing. It might be helpful. So that could be maybe like one use case. But from like our perspective, I think like we saw before some issues with pod startup latency, for example, that you presented here, right? And I think we saw like on the node level as well. So it might be useful for us, I think.
Yeah, I think I certainly can imagine use cases that when it's useful for debugging.
Yeah, like with Docker before we had like some contentions, right? On the node level, I think. And
yeah, I think in general, we still don't have like super good understanding where we are spending most of time, or how the time is split inside the node for starting or even deleting the pod.
Yeah. I guess I think where this conversation is heading, I believe, is maybe a far cry, but if Benjamin, this is something you want to take a stab at, and you're interested in actually kind of taking some of these changes like upstream, you might want to see if there is some parts of it at least that you can try integrating with our tests, our testing framework. I guess the changes where you have to go add these trace points in the Kubernetes code, those will need like bigger discussion and like thinking through how we want to go. But some of the events of some information that may already be present today with let's say we have a Kubernetes API. That's one place where you can actually add traces to these tests, and I'm pretty sure like how Ethic Master is saying we'll use it a lot in investigation issues. All right, so I had another topic for today. If you can move on. So it's about this this change. I'll just paste the link here. I think the Kasham made this change. I think you're reviewing it. So this change, it seems like this one is adding, making list calls weigh as multiple seats in APFQ, and there is I think couple customer issues we ran into recently, and I see Pratik from the AWS side has joined, so I'll let him speak more about it. But I think the main I guess the main thing which kind of was coming out of it for me was that change. If we tested it using our test today, the the load and density test that we run today, I think it wouldn't have actually exercised this enough because our tests don't create really any load throughput. Do you know Wojtek? Because as you reviewed that change, if there's some separate test done for this, or should we actually enhance our tests to kind of maybe add like a measurement for just creating load, like list throughput or something like that?
We were testing it a little bit like out of tree internally in Google, but can you explain what the actual issues were? Because like,
yeah,
certainly there are things where it can be improved, but that I want to understand where.
yes. So I'll have Pratik.
How exactly, because we also seen a bunch of cases where it actually helps a lot, and like the cluster would fall down without this, and it survived with.
Yes. So yes. So these cases we're seeing maybe outliers. I guess Pratik, you should speak about.
Yeah. So thanks, Sham. So the edge case that we are seeing is if a customer is making, or if a user is making large number of list calls, and now they are upgrading from a version which didn't have this functionality, which is 122, and this was added in 123. So what they're seeing is their list calls are now taking large number of seats. So some of the other calls that fall in the same bucket are basically getting 429s because there are no more seats for those calls, which was not the case in 122. So and this started happening right after they upgraded from 122 to 123. And in the metrics, we can see that the 429s and the reject calls, those also increase as a result of the upgrade. But from their side, there was no other increase in the load or the list call pattern that we checked.
Yeah, I think that in general, like because we've seen that too, and the reason for that is primarily that we are not tuned well enough, especially in terms of like defining the capacity of the API server. So so basically defining or increasing the number of in-flight seats in the API server is the or adjusting this value is like how we believe it should be solved. I mean, the exact sizing function also is far from perfect here, and it can be improved. But in general, like I think that the adjusting like how many in-flight seats that the API server has is what or how we should adjust that.
So Wojtek, I totally agree that this makes sense that we weigh heavier requests with more seats. I feel that probably the miss with that PR is when doing this, because it is also sharing the bucket with other requests, which may like mutating requests, which may be high priority. Maybe we should have done that along with maybe separating the bucket for list calls altogether, because in the end, we actually ended up doing that for this customers. We created another bucket which will divert the list traffic, and we can separately throttle that without affecting the mutating request. So maybe, but I see also how it may be hard to come up with such a new bucket with respect to how many concurrent features and stuff to have. But maybe, do you think it makes sense that this change should have gone along with that sort of a change?
Yes,
I'm not sure. I mean, it's certainly like a reasonable mitigation for some of the customers.
Timeline set out in the Slack.
Sorry, I'm not sure. It was your echo from your side, Shyam, or
no, I'm in the office. There's someone beside.
Okay.
Yeah.
So I guess I think it's certainly a reasonable mitigation to that problem too. I wouldn't do that by default for everyone, because in a typical use case where customer or the user is not actually overloading in some sense the API server, I think they generally don't want, or they generally want to share the priority level between like different types of calls. I mean, both mutating and reads. So I think what we could do better is certainly documenting it and like making more like release note required and stuff like that, and
Yes,
documenting
that's
what
my
are the
next.
potential mitigations and so on. But I'm not sure we actually should have like by default separate that. If that makes sense.
Yeah, and also to go back to Sham's original comment about around testing. So, and you also mentioned that the estimation is still not perfect. So let's say we in APF we go and improve the estimation algorithm, and tomorrow, like from maximum seats for any reason, it is now we're bumping up to like 20 or 50 seats. Then again, we might run into this issue, right? Like unless we have these kind of testing, which can include this case from like either cluster loader or some kind of perf test. Do you think we should be enhancing those at least in our upstream test?
Yeah, we certainly. I mean, the fact that we are missing tests is, I certainly agree. So like, if anyone has capacity to like extend our test or build new ones to exercise these scenarios, I'm all for it.
Yeah. So maybe we'll take that. But you can take it back as one of the AIs to kind of maybe enrich these cluster loader tests to like add some parallel unit, which makes it spot. But yeah, I think this.
You can also talk to Abu from Red Hat. I will paste you his LDAP here on the chat, like, because he was actually also looking into that and performing a bunch of like tests internally in Red Hat. I think I've seen some demo or presentation or summary from him at some point, like those 2 years ago, but I can't remember exactly what those were. But certainly he was also doing those, and he may either have something still around or may be able to help with running some of those tests or designing or reviewing or whatever.
Also, I think like there is a relevant test that Łukasz implemented recently for streaming lists, right? Like it's different, but it also exercises like just bunch of lists with the default flag and
I think
disabled. So
yes, I think at least reusing some of the code that is there, like can be, is definitely possible there.
Or maybe even like extending his test, right?
So I think it's a reasonable ask to have like good confidence that we're not missing.
Sorry, Marcel, you mentioned who added these tests recently?
I will post his nickname, but I will not type it right now.
Sure.
It's like polynomial, but with some zeros somewhere.
Okay, or if you could point me towards the tests that I can reuse for enhancing these tests.
Yeah, I'm just looking for that, and I will paste it here. And what we probably should paste it
Thanks.
into the notes too.
I guess really, I think what has ended up happening is multiple people have written multiple different tests for these specific lists. Internally, we've also done some tests.
I think it's
Hey guys, I am interested and have a slightly tangential question on this discussion. I was wondering if there is any generic guidance to come up with good priority and fairness policy for list calls or watch calls in general. We are working on experiments where we need to find out at what point API server breaks in concurrent list calls. So I was just curious, and it's related to the discussion. If anyone has pointers, I'd be curious to read.
Yeah, I think that was one of the callouts from the earlier discussion. that we'll probably need to have a somewhat better guidance around this, especially like maybe figure out, like today we already take care of defaults, so that come with each release, but I think we need to do that. I guess what it's followed about release note.
I think they just increase priority as we saw.
Whenever we change
Major bugs that we've had last.
change any major behaviors.
Like it was planned as part of the need for something. We absolutely need skill lists. This work was already planned. It's just required.
I think
And the potential.
one thing though is, yeah, I guess we missed the release note for this particular change. Or I think you mentioned this earlier. That is also my other call out. I think what we needed from a release note is, hey, the behavior is changing this way, and how we can make it if we want to kind of failures.
Yeah, I guess it's too late now to add it because no one will read this release note now, given that 122 is already out of, or 123 will be soon out of support window even. But I think updating the documentation in general is something that we still can do, and that is something that people are looking at.
Yeah. So okay, sounds good. All right. So for the testing gaps and like this idea about can we split list calls in our defaults itself to a separate bucket, I'll open a separate issue maybe to discuss this. But in general, actually, the fact that this change went out, and besides 2 customers, not many people saw this, actually is a good sign that this change is actually the right change. And this did not, these particular cases may just be corner cases, because like you said, 123 is not a long time ago, and a lot of customers have. So overall, I think I just want to give the credit to this change that it is right. And just need some more cleaning. I think we're way over time. Now we should find out.
Okay, then thank you, and see you in 2 weeks.
Yeah. See you all. Bye. Thanks.
Bye.
Bye.